Welcome to The Explainer. I am so thrilled you're joining us today because we're going to tackle a topic that honestly hits incredibly close to home for anyone who has ever spent way too many hours just staring at a code base. We are dedicating this entire explainer to preventing one of the most frustrating, time-wasting disasters in software development, the recurring bug. So let's just get right into it. All right, I want you to think back to your last major project. Now, we all know bugs are just a reality of building things, right? They happen. But ask yourself, what is the one specific kind of bug that is just way more annoying than absolutely anything else? It's not a missing semicolon. It's not some random server timeout. It's this. It's not a new bug. It is the exact same bug, coming back from the dead like some kind of zombie. Seriously, imagine this. You put in the hard work. You fix a super complex issue. You ship it, the team celebrates, and then, 6 months down the line, someone else touches the code, they have absolutely no idea about the history, and they quietly undo the exact fix you shipped. The bug goes right back out to your users, and now you are forced to re-diagnose and refix a problem that you literally already solved. Okay, let's really break this down. To stop this cycle, we first need to clearly define our enemy here. A regression in software is simply when something that used to work correctly suddenly stops working correctly. And the real kicker? This usually happens because of a change made somewhere totally different in the codebase, often by a developer who had absolutely no idea they were messing with that original behavior. And that brings us to the hero of our story, the regression test. Now, a regression test is not just some general, broad feature check. It doesn't just ask, hey, does this app basically work? Instead, it is highly targeted. It's essentially saying, listen, this exact broken behavior existed once. Here is the mathematical proof it doesn't exist anymore, and here is a permanent tripwire if it ever tries to come back. It is quite literally a message to the future, to another developer on your team, or honestly, even to future you, who just won't have the context that you have right now. Section 1, Anatomy of a Regression, the match_vendor trap. To really understand how this plays out in the real world, let's look at a concrete example from our source material. There was this bug in a tool called Toolport involving a function named match_vendor, and it brilliantly illustrates this exact trap. The old flawed logic was checking if a vendor's keyword appeared literally anywhere inside a full URL string. So, say the system was looking for the vendor's stripe. If a user visited a URL like example.com/products/striped shirts, the system would incorrectly tag it as the vendor's stripe, just because the word stripe showed up in the path of the URL. The fix, of course, was to parse the URL properly so it only matches against the host domain, in this case example.com, and completely ignores the rest of that string. Now, what's really wild about this approach is the mindset shift that's required to properly test it. A good regression test isn't just checking, does match_vendor work in a normal scenario? A vague test is never going to catch that weird edge case. Instead, you have to deliberately construct the exact trap that caught the old code. You literally have to feed the test a poisoned URL, one with the keyword sitting right there in the path, like striped-shirts, and then assert that the new, fixed code handles it perfectly and doesn't get fooled again. Section 2, a tale of two timelines, with and without the test. So we have our fix. Awesome. But what happens next? Let's run a little thought experiment here, picking up 6 months after the original issue is closed and everyone has completely moved on. Let's start with the darker timeline. Step 1. Your brilliant fix ships, but you skip writing the targeted regression test. Step 2. 6 months later, a totally well-intentioned new contributor decides to refactor that match_vendor function just to make the code look a bit cleaner. Step 3, because there is nothing loudly announcing, hey, don't change this specific logic, they accidentally simplify the parsed host string right back to the full URL string. Step 4, the code compiles perfectly. Every other general test in the suite passes with flying colors, the pull request looks super clean, and it merges. Step 5, boom. The zombie bug is back, silently wrecking data until a highly frustrated user has to report it all over again. I really want you to let this quote sink in for a moment. The fix only protects you until someone unknowingly undoes it. This right here is the hidden compounding cost of skipping that one extra step. Without the test, your brilliant fix is actually incredibly fragile. Now, let's rewind and move to timeline B to see how this builds a safety net. Same contributor, same well-intentioned refactor, same accidental reversion, but step 2 changes absolutely everything. The second they open their pull request, your continuous integration, or CI, pipeline runs automatically. Step 3, instantly, a test named does not underscore match underscore vendor underscore keyword underscore in path fails with a giant glaring red X right there in the pull request. Step 4, the contributor reads that incredibly clear test name, realizes exactly what they just broke, and they fix it before a single human reviewer even has to look at the code. Crisis averted. And this brings us to a quote that just perfectly summarizes the entire value proposition of a regression test. It turns tribal knowledge into an automatic, permanent check that doesn't rely on anyone remembering anything. You don't need the original developer in the room. You don't need to give a history lesson on a Zoom call. The code just remembers for you. Now, you might be sitting there thinking, well, I work alone, I've got a great memory, I remember my bugs. But the data shows the value of these tests actually scales exponentially based on two crucial things: the number of people touching the code and the amount of time that passes. As your projects grow, natural contributor turnover and just basic human memory loss pretty much guarantee that tribal knowledge is going to vanish. The test is literally the only thing that survives time. Section 3. Building the perfect trap. 4 rules for strong regression tests. So how do we actually implement this in the real world? We know we need them for sure, but how do we make sure they actually work? The absolutely crucial point here is that not every passing test is a good one. A truly strong regression test requires precision, and there are 4 rules you need to follow. First up, it must reconstruct the exact failure condition, not just some vague approximation. Remember that striped shirts URL? You gotta use that. Second, it needs a crystal clear name explaining exactly what it protects against. Naming a test does underscore not match vendor keyword underscore in path tells a future reader exactly what broke. A generic name like test vendor 2, that tells them absolutely nothing. Third, and actually a lot of people miss this one, you have to verify that the test actually fails against the old buggy code and passes on the new. If it passes on both, it's not a trap, it's just dead code. And finally, it must run automatically in your CI pipeline on every single change. If a test only lives on your local machine and requires you to actively remember to run it, it is virtually useless. When you follow these rules, something kind of magical happens to your project. Every single bug you fix teaches you something the codebase itself doesn't know yet. By writing a proper regression test, you aren't just proving your fix works today. You are leaving a permanent, automated guard standing at the exact spot where the codebase used to be fragile. It's a gate that simply stops the exact same mistake from ever happening twice. Which leaves us with a final thought I want you to take back to your own workflow today. Because look, fixing a bug, that's an achievement. But preserving that fix forever, that is a discipline. So ask yourself, how are you preserving your hard-won bug-fixing knowledge so the code remembers, even when you inevitably forget? Are you just relying on memory and luck, or are you actually building permanent tripwires? Thank you so much for exploring this with me today on The Explainer. I really hope this helps you banish those zombie bugs for good. Catch you next time.